In this video, let's have a look at the concept of cross-elasticity of demand, which is arguably the most difficult concept of elasticity. It's harder to relate to, it's harder to understand. But I hope that with this example, I'll be able to prove algebraically how it works and also intuitively, logically, how it all makes sense. So let's get started. Now, first of all, I wrote the formula over here as a starting point. So what is cross-elasticity of demand, which we note as XED? Percentage change in quantity demanded of a product X over the percentage change in price of a product Y, meaning that we have to consider two products in order to calculate this elasticity. That's why it's called cross elasticity, because we are considering two products. Now, of course, in order to have a meaningful elasticity, the products have to be related somehow, and we know from microeconomics that products that are usually related are either substitutes or complements. If cross elasticity of demand is zero, that means the product are unrelated, such that the price of product Y has no effect on the quantity demanded of product X. Now, let me show how this cross elasticity of demand would work when there is actually a meaningful relationship between those two products. Consider the example of apples and bananas. These are our two products, okay? I will consider the apples and the bananas. I will give an example with numbers that I made up myself, hopefully to prove my point that I'm trying to make. Now, suppose that the price of apples initially used to be $2, okay, per kilogram. Now, the price of the apple, this was initially, let's say the final price now, it became $1 on the market. Apples became cheaper in simple terms, okay? So therefore, the percentage change in price of apples is equal to price final minus price initial over the price initial, which is $1 minus $2 over the initial price of $2, which becomes minus 1 over 2. And I'll leave it as a fraction, okay? Because given my example, it will be easier for me to work with fractions. Minus 1 over 2 over here is going to be the percentage change in price. The negative sign shows that the price decreased. There's a negative change, okay? Now, suppose that since I have to consider both products, like I just said, so I just consider the price of apples, which is concerning the denominator in our formula, okay, the change in price, and I am considering apples as that product. I want to look how the quantity demanded of bananas will change, which has to do with the numerator in our formula. Now, suppose in our example that the quantity demanded of bananas changes in the following way. Quantity demanded for bananas used to be initially 150, but now, so this was initial, quantity demanded for bananas finally on the market is 100. Logically, intuitively, why would this be the case? Because apples became cheaper, so people started buying more apples and less bananas. They substituted bananas for apples. That's why quantity demanded diminished for bananas. Hope this makes sense. Now, algebraically, we have percentage change of quantity demanded is going to be quantity final minus quantity initial divided by the quantity initial, which gives us 100 over here minus 150 divided by the initial quantity of 150, which becomes minus 50 over 150, which is the same as minus 1 over 3. Now, with that being said, let's put these things together and calculate the cross elasticity of demand. Let me change colors real fast and I will do it over here. Cross elasticity of demand is going to be the percentage change in quantity demanded, which I calculated over here, and we saw it's minus 1 over third. So let's write minus 1 over third divided by percentage change in price, which is minus 1 over 2. So minus 1 over 2. Now, minus with minus cancels out, so we have 1 over 3 times 2 over 1, which becomes 2 over 3. So 2 over 3 is a positive value over here. It's not negative. What does it tell us? Let's reason. It tells us the following, that when, I'm gonna write it in an English sentence, okay? When price of apples okay, price of apples, since we are talking about apples and bananas, when price of apples increases by 1%, then quantity demanded for bananas increases by over here 2/3 is going to be 0.66, so 0.66%. Now what does it tell us? What kind of elasticity is this to begin with? Well, 0.66, okay, is between 0 and 1. So what does this tell us? 0.66 is somewhere over here. Well, that was an inelastic demand, wasn't it? Inelastic demand. This is the criteria for an inelastic demand, the range of values for an inelastic demand. How does this work out? Well, let's have a look. If apples become more expensive, people switch to more bananas. That's why quantity demanded for bananas would increase by 0.66%, at least based on our example. This is the logical reasoning behind it. However, why does it increase only by 0.66%? Why is the change so low? Why do we have an inelastic demand over here? Because apples and bananas are not that strong substitutes. Apples have their own taste and bananas have their own taste. So they are not really that close to each other. Therefore, when apples become more expensive, yes, some people will give up some apple consumption, but not by a large amount, because the bananas, okay, or let's say the apples, even though they're more expensive, they still provide a good taste to many consumers and they want to buy them even though they're more expensive. However, to a certain extent, they will start consuming a bit more bananas just because they are more affordable. So what I'm trying to say, let me just zoom out to get more space to make an important note. I'm gonna zoom out a bit, move to the right. What I'm trying to say is the following, that when we have an inelastic demand over here, a cross elasticity of demand that is inelastic, this happens for products that are not very close substitutes, okay? However, if we had the following, if we had that the cross elasticity of demand over here would have been, let's say, 2.1%, okay? Instead of 0.66, we would have had 2.1. We would have a very elastic cross elasticity of demand. It would be very elastic. Why is that the case? Because those products are very strong substitutes, meaning that if apples become more expensive by 1%, people would react very significantly to that change in price, so therefore they would drastically reduce their apple consumption and go for banana consumption, and they would increase the quantities of bananas demanded on the market by a significant amount, okay? In this case, hypothetically, if that would be 2.1%. Anyway, hope this all makes sense, and we are done.